Hi, and welcome to Lesson 3.6, Parallel Lines. So for parallel lines, again, you already know parallel lines exist in the same plane and never intersect. Now we're going to build off that idea into a couple different relationships and vocabulary terms. So the first thing that we want to realize is if we're dealing with two lines, M and N, and they are intersected at different points by a third line, that line would be known as a transversal. So in this case, M and N are two lines. If L is intersecting both at different points, L is a transversal of M and N. Then, if we're looking at the transversal, we can figure out a special relationship between an angle pair known as corresponding angles. And corresponding angles are in similar locations with respect to the transversal. So, for example, looking at this figure at the right, angle 1 is corresponding to angle 5 because if we look along the transversal, 5 is in the upper left of where it intersects line N, and 1 is in the upper left of where it intersects line M. So both are in the upper left along the transversal, so they correspond. 2 corresponds with 6, both are in the upper right of where the transversal intersects the lines. 3 and 7, both in the bottom right, and then 4 and 8, both in the bottom left. Then two other vocabulary terms, just so that you know them going forward. The interior, so when we're looking at two lines cut by a transversal, the interior is the space between the two lines. So on the interior, we would have angles 4 and 3 and 5 and 6. The exterior is the space outside, so not in between the two lines. So our exterior angles would be 1 and 2 and 8 and 7. So the corresponding angles matter because we have a postulate based on them that states two different parts. So if we have corresponding lines cut by a transversal, or if we have lines, cut by a transversal, the corresponding angles, if they end up having the same measure, meaning they're congruent, then the lines are parallel. So if we had angle 6 up here congruent to angle 2, then we would know lines M and N are parallel. Obviously, in this drawing, they are not. And then the converse of that, so the corresponding angle postulate as the original, if the corresponding angles are the same measure, then the lines are parallel. The converse, if the lines are parallel, then the corresponding angles have the same measure. So if they told us that the two lines are parallel, then we could figure out corresponding angles have the same measure. So what I just covered in those parts A and B is more in depth explained here from the book, explaining the relationship. But there are a couple things we want to look at. We can tell M and N are parallel because on those lines, it's hard to see here, it didn't print well, but there's an extra little arrow. If those arrows match, it tells me those two lines are parallel. So if M and N both have that little arrow marking inside their lines, they are parallel. So then we know if M and N are parallel, angle 1 and angle 2 correspond. So we know angle 1 and angle 2 are congruent or equal. So we can use that idea here in example 1. So M parallel to N, and I italicize mine or slant them a little, but two vertical lines or two vertical lines slightly slanted is the symbol for parallel. So this would be M is parallel to N. They want us to find the measure of angle 7. So I'm looking for the measure of angle 7 down here in the bottom right. So we can use what we know to figure that out. Well, 7 corresponds with 3. So if I can figure out 3, I could figure out 7. Now, to figure out 3, I know 3 and the 85 here make up a linear pair because they create line M. So 3 and 85 make a linear pair, meaning they add to 180. So if I did 180 minus the 85, I could get the measure of angle 3, which is 95 degrees. Then I know measure of angle 3 is equal to the measure of angle 7 because they're corresponding angles. So the measure of angle 7 was 95 degrees. Now, we're going into a slightly different idea here of finding the slopes of lines. And the reason that slopes matter, you'll see in a minute, there's a special relationship with slopes and parallel lines. So if we have a line like an A, where it's written in standard form, we would want to rearrange that into slope-intercept form, y equals mx plus b, to find our slope. And remember, slope is always the lowercase m, so what's attached to x when we're in y equals mx plus b? So in part A, I want to solve this equation for y. So I subtracted 2x from each side, and I have a negative 5y equals negative 2x minus 10. Divide everything by the negative 5, and y would equal 2/5 x plus 10. So what's attached to the x in place of m is 2/5. So the slope would be 2/5. In part A, if y equals a number, that means we have a horizontal line. So if y ever equals a number, we have a horizontal line, and the slope of any horizontal line is 0. If x equals a number, then we have a vertical line, and the slope of a vertical line is always undefined. So horizontal line, slope is always 0. Vertical line, slope is undefined. And why the slopes matter is stated right here. Parallel lines and slopes theorem says if two non-vertical lines are parallel if and only if they have the same slope. So what that means is if I have two lines with the same slope, I can say they're parallel. Or if I'm told two lines are parallel, I know that they will have the same slope. And then we have the transitivity of parallelism theorem, or more simply put, the transitive of parallel theorem. So transitivity of parallelism theorem is basically the parallel lines transitive theorem, which states if line L is parallel to line M, and line M is parallel to line N, then line L is parallel to line N. So if L is parallel to M, and M is also parallel to N, we then know L is parallel to N. So then in example 3, our last one for today, they want us to find the slope of a line parallel to this equation here, negative 3x plus 2y equals 8 minus 4x. So I want to rearrange this equation into slope-intercept form so I can see my slope. So I'm going to start with adding 3x to each side. So 2y would equal 8 minus x. Then I just want to rearrange it so the x is in front. So 8 minus x is the same as negative x plus 8. Divide everything by 2, and y would equal a negative 1/2 x plus 4. So the slope of this line is a negative 1/2. So the slope of all lines parallel to it would also be a negative 1/2. So your main ideas for today can be summed up in these two theorems right here and the idea of a transversal and corresponding angles.